Hi everyone, good evening. My name is Shay Hummel, and as David presented, I'm the Director of Knowledge Mining here in SparkBeyond. SparkBeyond empowers companies with AI-powered solutions. Today, I'm going to share our experience with creating an NLP-based engine and the reasons that got us to collect data and increase the quality of the results that we provide our clients. So first thing first, I will present the platform which uses the NLP engine. The platform is called Research Studio. Then we will dive into the specific engine, knowledge mining engine. We will talk about what led us to collecting data, and finally we will talk about what we did with this data and its effect on the final results. So let's start with describing Research Studio. So Research Studio is a platform for general purpose research. The user of Research Studio provides a subject. The subject may be every subject or any topic that the user wants. It can be, as you see here, solid state battery. It can be a location like Germany. It can be a company like Google. It can be whatever you want. And the researcher may ask any question she would like by providing something that we call relation. The relation captures the question that the researcher is interested in. As the research continues, the researcher may research other deepened stuff. For example, if the original search provided these results, for example, a solid state battery, and the producer is, we see here, Toyota and Samsung, we can ask additional questions and get additional answers. Basically, we change the way researchers are doing research by, first of all, providing the exact answer to the question that they are interested in. If you ask yourself what's the way that you are doing research, you are going, I guess that you are going to Google and going over the first links, and then inside each link you are trying to find the exact answer. The paradigm that Research Studio is trying to implement is one which we first of all provide the exact answer, the most exact answer that we found, and we support the answers with snippets that we found over the web. Actually, it's not just over the web. We are searching over the web, as I told you, but we are also using Wikipedia, patents, research publications, and a lot more data. We have a huge amount of data in-house, which we are using for this system. So behind the scene, we have the knowledge mining engine, Knomi for short. This is how we call it. So as you probably guessed, knowledge mining, Knomi gets as an input the subject and some kind of a relation. It's doing its magic and returns to the platform the answers, the concrete answers, where each answer is backed up by some evidences, by snippets that we found for that answer. Let's dive into the implementation of the engine itself. So we start with a recall-oriented phase. The recall-oriented phase is one where we go to the databases that we store in-house and we also go to the web, we are trying to retrieve snippets which are on the subject and related to the subject via the relation. The next phase is, given the snippets that we found, we are trying to extract the answers themselves by using BERT Squad 2, and we extract the exact answer, and it goes with the evidence that provided it. We also add metadata to the answer. The metadata may be Wikipedia linking, named entity recognition, part of speech tagging, and NLI, natural language inference score. The next step is deduplication. As you can see here, that there are cases, and actually there are a lot of cases, where we get answers which probably refer to the same entity, but we don't want to show we don't want to show to the user both Blackstone and Blackstone resources. They are both refer to the same entity. So we have the results go through a deduplication phase, and finally scoring. Originally, the scoring was done based on the amount of evidences that each answer had, which is kind of a good paradigm, or kind of it worked well for a while, and we got very good feedback from our clients. However, our clients wanted more. They wanted to get the top results as good as possible, and they wanted to not, they didn't want to go over the entire list. They wanted to get as precise results as possible at the top of the list. Let's have a short look at how a single output from Knomi looks like. So if the user inputted methane and asked for applications of methane using the relation used for, our user got fuel and a snippet with methane is used as fuel, etc. So it really shows the evidence for that answer. As for the client feedback, once we got that feedback, we knew that we needed to collect data. We needed to collect data in order to increase our precision, in order to make our results better. So let's see the first labeling task that we had. It was a labeling task that we did in-house inside SparkBeyond, and the feedback that we got for that labeling task was, oh my God, this is horrible. I don't understand the labels. And as you can see, the labels here are quite, looks alike. They're textually more or less the same. There's a yes here, yes here, yes here, and one no. So we needed help. We understood that we are not doing the task right. We are not defining it correctly, and with the help of Toloka, we defined a new task. The task was a much simpler task. We wanted to capture the main effect of the system to our user. And in order to do that, we asked us a much simpler question. Given the question, the answer, and the snippet, is the answer correct given the snippet only? We require the labelers not to know anything or disregard anything beforehand. So the new task looks like this. What is methane used for? The answer is fuel. As you can see, it quite resembles to the first task. the snippet is the same, and the only thing that the labeler needed to do is write yes or no. It was a simple yes or no task, and it worked very, very well. Before I go to this slide, I want to say that when we define the task, and this kind of answer one of you guys' questions, when we define the task, Toloka really helped us define the task, define the control question, define the control measures to verify that the task is being done correctly. I want to show you an example. So which company manufactures laptops? And we have the answer Intel. If one want to read this snippet, and this one is used as a test question actually. If one of the labelers didn't read the snippet, and she has, and maybe the labeler has some prior knowledge, the answer to this was yes. But with the help of Toloka, we defined these kind of test questions. And if you will read the snippet over here, you will see that actually Apple is the one which manufactures laptops, while Intel, provides the processors. Another thing that Toloka helped us to do is there are cases where the snippet is very long and has some difficult concepts, which seems weird. And one of the things that we defined in the task was a minimum time for each task. And this is one of the quality measures that we imply in the task. This also helps us keep the quality of the results that we get after running tasks in Toloka. Shortly summing up what we saw thus far, we have Research Studio, which is a platform for general purpose research. Research Studio is using Knomi. Knomi is an NLP-based engine to extract answers and provide evidence for these answers. We needed to improve its quality, and we did it with label data. So after a few iterations of running a labeling task over Toloka, we got to 12,000 different labels over 48 different inputs. And we got to a baseline of 76% precision. And we asked ourselves, okay, what can we do with it? It looks okay, but we want more, we want better. And in order to get to do better, we used another product by SparkBeyond. I'm not going to get into the details of this product, but I will say that it's the discovery platform is a product which helps data scientists get new insights by exploring the data and generating a lot of features, trying to find features which really explains the label. And in this case, we also used the discovery platform to explain the data that we got from Toloka. On one hand, we have label from Toloka. On the other hand, we have our data, our output from Knomi, and we wanted to understand what explained the label. And we saw that there are features related to the subject and the answer, and we took them. We also saw that features coming from BERT, the scores from BERT, are also significant. And finally, answers with Wikipedia linking are quite good features. Using XGBoost-based predictor, we trained it, and as we collected more and more data, you can see the precision increases. We started baseline at around 81%, precision at 50. not the overall. The precision at 50 is around 81%, and today we are at around 94% precision at 50. And the precision at 100 acts more or less the same. It also started at around 76%, and we are now at 90% precision. So what we learned from this work. So labeling is hard work, and Toloka really helped us come up with a good task, a good quality for our results, and it went really fast. Data is the new oil. I don't think it's anything new to anyone here in the room. Collecting labeled data really changed the way that we are doing our work. We have a baseline, we know where we stand, we know that we can analyze it, come up with new features, come up with new insights, and we are planning to automate the entire process of labeling, getting the label, training the predictive model, and deploying it to production. Today it's manually done, but later we are planning to do it automatically. Behind the scene credits and stuff. So Dimion, Tal, Joanna, and Yuval. Yuval is not here, but credits to all of them. Questions?
So what other options did you consider besides Toloka? Did you try anything else, or was Toloka the first option that you considered?
So one of the options that we tried is sitting here in the audience, so I'm not sure that I want to say anything about it at the moment, but we tried both. We tried one of the leading providers in the industry back then, and we tried something small. And actually, we got to Toloka by accident, and I think it was a good accident.
And then Toloka came to Israel.
Can I apply this awesome system to internal knowledge base that we have?
You mean?
Not scraping Wikipedia or so. Given that I have a knowledge base and I want to have this Q&A system that you developed.
Let me see if I got it correctly. You are asking if you can give us your data and run this system over your data. Feature on the pipeline, actually. Okay, thank you.
No. We have time for one more question. If anybody
okay.
In the audience?
Yeah, of course.
People. So I assume you have a duplication in the labeling. What did you do with this incident of duplication? Because labeling by person, it's a bit.
This is a good question. So we encourage actually duplications. Each question that we ask is labeled by 3 to 7 people. And we are doing it in order to increase the confidence we have in each answer that we get from Toloka. And again, this entire, I was previously aware of this feature, but for example, measuring the time to answer, or the getting the right person for the task is something that Toloka configured for us with the features that they have. So there are a lot of features inside Toloka, a lot of conditions that you can set in order to verify that the confidence is high, the confidence that you get. Yes, actually it's automatically. Okay. יש עוד משהו?
No.
Okay. One final slide. So, please.
Yes.
Final slide. So we are hiring, and we have open positions in SparkBeyond, and specifically in the Knomi team. We are hiring a Python engineer and senior NLP and junior NLP. So come work with us. It's fun. It's very, very interesting. We'd appreciate if you'll come.
Thank you, Shay.